Welcome to Insight Builder channel. Evolving missions from functional to object-oriented paradigm. Part 2 of two-part series. We had discussed in the last video the how, the why, the what of the object-oriented programming, and also we had introduced the turtle module, the turtle demo, and we had completed to build a rectangle figure procedurally by typing code and then creating a script in part 1. What we are going to do now is we are going to use a functional paradigm initially to build a similar rectangle and draw it, and after that we are going to create an object called as rectangle using Python object oriented programming, and then we are going to make it to draw itself. This is the brief intro about this video, so we will dive directly into the procedural rectangle script. So this is the script that we wrote in the last video. I'm going to zoom in so that you guys can see it better. This is the script that we have written. It's pretty straightforward. We start the script at this particular checking, where we check whether the script is the main script itself, and then we start getting a turtle object called as t1, and then we get the input. We are waiting for the user to give the input as enter, and then we start building the rectangle. So let me execute this code for you guys to see what happens. Procedural rectangle. The code script, everything will be available in the GitHub repo. The link will be shared below. And I'm going to make this. Yeah. So now I'm going to press enter here. The moment I press enter here, the turtle completes the rectangle and it says that it is done and it is waiting. So I'm going to close this window and it goes off. Next, what I'm going to do is I'm going to make this particular script that I've written here into a function. How to make a procedure that we have written into a function? First thing that we need to do is we need to check what inputs are required from the user and what we need as a recipe. So we have to get some information. We have to have the turtle module. First thing is we need to import the turtle module and we need to create this object, the t1 object. We have to create this. Basically, we have to initialize this, and we have to give it as an input to the function. That is first thing. And next, we need to provide the color of the rectangle, color of the border. And then we need to provide the pen size. All these things are variables that we can modify. And once we decide those things, then we can decide what to use and what not to use. We have the length of rectangle, and then we have the breadth of the rectangle, and finally the home. So where we want the rectangle to be, this is one of the important idea that we need to think, because the canvas is pretty big. We can make the rectangle to start anywhere, to be placed anywhere. So we have to provide the coordinates of the home. All these things we have to provide. All these things that we right now decided are going to be the arguments to the function. If you don't want these many arguments, you can decide to make some inputs constant. So we can actually say the color to be constant. We are not going to change it. We are going to say the pen size is going to be constant. We are not going to change it. And moreover, the turtle that we are going to create has to be initialized when we are going to start the program. That is something cannot be constant. So we have to provide that as a separate argument to the function. So this is how you first of all think about designing the function. And what is the output of the function? We already saw. We saw just now, executed the code, and we saw how the rectangle has to come out. So we have already seen that. And once the function completes it, it can either say, it can just print done and tell us that it has completed, and or else we can make it to write something. All these things are possible. So coordinates we want to make the coordinates to be different. We don't want multiple rectangles to be placed in the same location. We want it to move to different, want the turtle to move to different location and then create the rectangles there. So that is our intention. So let us start building the function. The functions are always built before the main code execution point. So we are going to build the function here. And to build a function, we need to first of all define the function. So build rectangle, and we already decided what are the inputs that we are going to give. So first is my turtle, and the next is we are going to give x coordinate, x coord, y coord, and we need to provide the length and breadth of the rectangle. Apart from this, all the other things are going to be constant. If you want, you can provide the variable details of all these things, all these arguments here. So you can say this is going to be a turtle object, t dot turtle, t dot turtle object, and we can say this is going to be an int, and same way this is going to be an int, and this can be floats. If you want, you can make it as floats, or else you can keep it as int also. That's a lot of arguments. And what we can do is we can actually make some part of these arguments constant, but in this case we have to change everything. So we have no choice but to provide all these inputs. So next we are going to build the turtle inside the build the rectangle inside this function. So for that, all you need to do is take all these things from here to here, because that is going to be a little bit different. We're going to take all these things from here to here, and we are going to go here, and we are going to paste it. And instead of t1, we are going to modify the t1 to be my turtle, because that is the turtle that we are going to use and build the rectangle. So, we are going to use my turtle. The pen color, okay, the pen size has been missed, so let me pen size is also there. Okay, from here the rectangle is getting built. First, when the turtle is going to move forward, it is going to move forward to the length of the rectangle, correct? And then it is going to turn, and then it is going to move to the breadth of the rectangle. So visualize it. I can actually run the code again so that you can see what is happening, and then we can decide how to proceed. So here, if you see, I'm going to press enter and see what happens. So first it goes forward, turns, and then comes back. So it goes forward, it turns, writes this particular line for the breadth, and then it turns here, it comes back to the length of the rectangle, then again it moves to the home. But this part we have to change, because we have to move to the x coordinate and y coordinate. We should not actually move it to the home. For all the turtle, the home is going to be this point. Whether it is going to be the first turtle, second turtle, or first rectangle, second rectangle, this is going to be the home. So we cannot move it to the home. So we have to first of all move the turtle to the coordinate where we want to start it, and then we want to draw the rectangle, and then we want to close it. So that means here we have to first of all move the turtle using the goTo method, and we have to move it to the x coordinate and the y coordinate that we are going to provide. So that is the first step that we need to do. But for that movement, we don't want the turtle to write anything. We don't want the turtle to create a line there. So for that, we have to say pen up. So if you say pen up, it will not write. But after it has gone there, we can ask the turtle to put the pen down to write the to print the line. So I'm saying write in the sense of what the program or the turtle will do. I'm going to say pen down. For all these steps are just initialization part. So keep this in mind. The same kind of initialization part will be required for the objects also. I'll be discussing that as we go forward. This is the part where we initialize the turtle, the position. And then once it has gone there, it is going to execute all this step. And then once it completes to this location, we have to ask the turtle to go to the x coordinate and y coordinate, right? Because that is the home of this particular rectangle. That's what we want to do. And once that is done, then we can ask the turtle to print done. So this print done will occur in this location, as you see here. So let me close this. Let me make this bigger. So we have defined the rectangle, and here it says that it has to have 2 spaces. So I've created 2 spaces here, and this particular squiggly line is happening because I have created a pretty long line here. So I'm going to make it tidy. Once you start using VS Code and start working with pylons, then your code will start becoming very, very neat. So that is one thing that I realized. Thanks to one of my customers who introduced me to this particular extension. Okay, now that we have defined the rectangle and also we have modified, yeah, we need to change this also. We need to make it as length. That was a mistake. That is going to error out. And rest of the things, I think it's going to work without any kind of a challenge. But we have defined the function, but we need to now call the function. So what we are going to do is, we are not going to use this series of steps right now. We are going to remove this. We are going to keep it there, but we are going to comment it out. And here I'm going to call build rectangle. I'm going to say build rectangle, and once I say build rectangle, it is initially asking me to give me the turtle. So I'm going to say my turtle is equal to T1. This is the turtle that I've already initiated here, correct? Next, I need to give the x coordinate. So x coordinate, I'm going to say that this rectangle has to be drawn at 50 x axis and y coordinate 150. I want the length to be 125 and the breadth to be 250. This is the rectangle I want, and I want one more rectangle. So the idea of creating functions is to show you that you can build any number of rectangles that you want. So the turtle is going to be still the same. We are going to use the same turtle, and we are going to ask it to build a rectangle at 200, and y coordinate is going to be 300. Length is going to be 100, and the breadth is going to be smaller. I'm going to make it 75. So let us see how the output comes. I'm going to execute this code, and again it is going to stop before it proceeds. So let me execute this, bring it here, change it so that you guys can see what is happening. And I'm going to press enter. So you saw it is moving and it is creating the rectangle, and it is done. So 2 rectangles have been created by using the single function, by modifying these coordinates. So you saw how easy it can be to work with functional paradigm. The challenge here is that if we want to add more modification to these rectangles, so what if I want to color this rectangle later, or I want to get some information about this rectangle, like the size of this rectangle, length and breadth of the rectangle. What if I need to get that information down the line in the code? It's not going to be easy, because I have given the input here, but I cannot get any output from this function. The only output that I can get from this function is this particular rectangle that is getting drawn. Rest all are vanished. After this function is completed, all the data is vanished. You cannot retrieve it until unless you have stored all these things as a separate variable, so which is going to create a lengthy program, right? What you are going to do is, now we are going to move this function and make it as a method inside a rectangle turtle object. before that, we have to actually have a small primer on object-oriented programming. So this is the build rectangle that we have done, and we are going to now start working on creating a class. In order to create an object, so we are now moving into the object-oriented implementation of this turtle rectangle creation process. So for that, we have to create a blueprint of that rectangle. So to create the blueprint of that rectangle, we have to use the keyword class, and we have to give a name that usually starts with the capital letter R. In case of rectangle, it's capital letter R. If it is going to be some other, then the first word should be uppercase. Rectangle turtle. So this is the name that I'm going to give, and I'm not going to inherit any object here, but by default, whenever you are going to create a class, and if you are going to create a rectangle turtle like this, this object class will get automatically inherited. You don't need to inherit it, it will automatically get done. Only thing is, you need to know what it does. So as of now, I'm not going to go into that part of object-oriented programming. It can be a little bit confusing. As of now, I'm going to use a turtle by manually creating it. I can use a turtle here itself. I can say I can do like this. I can say import turtle. Sorry, I have to say from turtle import turtle. So I can do like this, and I can import turtle here, and this will actually ensure that all the characteristics and the features of this turtle class gets imported into rectangle turtle class. So we don't need to create a new turtle for actually creating this rectangle turtle. This is a little bit advanced, so I'm not going to go into that route. So let me now go into the rectangle turtle and create the first initialization method that is called as init, and this init must have the various data points, the attributes, the features, or the parameters of the object that you're going to create. In my case, as we can refer to this particular function that we created. So we saw that sorry about the disturbance. We can refer to the function itself for the features and the data points that you want to create. So we are going to require turtle object, but this turtle object we are going to create it inside the initialization function itself. So we don't need that here. So but we need the x coordinate. So we are going to ask for the x coordinate, which is going to be an int, and we are going to ask for the y coordinate, which is again going to be an integer. If in case if someone creates the object with a float, then it will error out. So that is one of the ways of controlling how the object is created. So by using this int type that we are providing. Also, it's a class. Int, float, all are classes, and they are themselves create objects once we declare them. So breadth, we are going to create all these things, and you see that I am trying to make it a little more tidy, so later it doesn't create a problem. So once that is done, I am going to initialize this. So in order to initialize, first thing is I want a turtle, right? So I want to create a turtle. So that is going to be my turtle. And to create a turtle, I am going to use this simple declaration. So once I say this capital turtle with capital T and with open and close bracket, this means that it is going to create a turtle object. So object meaning it's an instance of that object. Basically, it will go to this particular turtle code. So let me execute this. If I press on F12, so if I click on this turtle, this particular word turtle, and in VS Code, if I press F12, it will follow this particular object's declaration. It will go there. So it will go there, And this particular object turtle is declared inside the turtle.py module. So you can see that. And this turtle has the initialization by itself. It has lots of internal details. And you might be wondering, this turtle class looks very small. So where are these methods that this turtle class can work? That is inside raw turtle. So this is what I was talking about, inheriting. So if I press F12 right now, it will follow that raw turtle and it will show me the entire class of raw turtle. And here you will see that the raw turtle has got a lot of variables that is getting initialized. This is how we have to learn in case if the code doesn't have a proper documentation, or if you want to understand how the code is working internally, then in VS Code you have to just use F12 and it will keep on following the declaration, and it will go to the implementation. So this is the declaration of turtle, and by clicking on F12 it will go to the implementation inside the turtle module here. So that is what I was talking about. This will be useful when you are using your own code. So you will be, as we go down the line in this series of videos, we will be making more complex code, and we will be trying to work with artificial intelligence models. As you will see that in the same playlist I am introducing PyTorch building models also in Raspberry Pi. So these two are actually linked together because we are trying to work with machines, right? We are trying to make machines to learn and build things for us. So these things have to go together. Anyway, let us proceed further, and we are going to say length is equal to self.length is equal to the length variable that we are getting, and same way self.breadth is equal to breadth. I think the self.x coordinate, these variables, that is under self is different from the variable that we are using it to create. So whichever is with dot self dot, it is going to be part of the blueprint. So whenever an rectangle turtle is created, all these variables have to be given to it, and all these variables will be different. So that's what I want to mention. So I have created the data part. So def underscore double underscore init. So this is a dunder method. It is having double underscore. It's called as dunder method. Def underscore double underscore init is going to get all the data of the object. Next, what you are going to do is we are going to create a method that will draw self. So I'm going to say draw self, and here I am only going to call self. So what will happen is when I call self here, this will be able to pull all this information and it can use inside the method. So that is how this self and this initialization is connected. I was talking about the demarcation between what an object can do and its characteristics. So this is the demarcation. So init double underscore init contains all the data, and the methods that we are going to declare right now inside the class rectangle turtle is going to contain what the object can do. That's the difference. So what the objects can do is usually provided with the verb and the object itself. So here the class name itself is a noun, and the methods are usually verbs. In that way you can easily find out that which is going to work and which is going to be just sitting there as data. So I'm going to take all these things. So you'll see that I'm using the same function that I just now created, but how am I going to use this there? So you'll be seeing that in a couple of minutes. Sorry about that. I'm going to copy all these lines, and I'm going to go here and I'm going to paste it, and I'm going to just modify it a bit so that it's aligned properly. And also I am going to, instead of using just my turtle, I'm going to use self.myturtle, self.turtle, sorry. So for that I am going to again select all these things and do this. I'm going to delete it I'm going to write self dot turtle, and that's all. So there is a bit of an issue here. So it's all aligned. Now we have created the object, and we have also given the object an ability. But now you see that there are a couple of errors here. So it is saying, the VS Code is throwing error that X coordinate is not defined. This particular, okay, there is a mistake here. We can remove this, it's not required. So these variables are not defined. So these variables are not defined because we have not attached self to it. So if we attach self to it, then this variable definition issue will vanish. So now you understand how the method is able to get, so this self is containing all these variables, and you can use that inside the method. You are not declaring the arguments here. This self contains all these arguments. And one more important point is you can actually get that information back. So that is one of the key aspects that I wanted to discuss when it comes to object-oriented programming. If you want to get back the detail of the rectangle, we can actually do that, because the self variable will contain the x coordinate, y coordinate, and also it will contain the length and breadth that has been used. So if, for an example, I can create one more method. I can say def give dims. So if I say give dims, and if I say self, I can say return, I can say print. If I call the method give dims on the rectangle object, it will print the length is self dot length, and breadth is self dot breadth. And same way, I can actually create one more method. So I say locate home. So if I say locate home of a particular rectangle, it will again, so I'm going to copy this so that it will be easier for me. The x ordinate is self dot x ordinate, and y ordinate is y dot y coordinate. This is the important aspect of object-oriented programming. So now we can get the information that has been used by the object to build something, which is not possible if you are going to use the function. So that is one of the quintessential thing that I want you guys to take today. So you can actually build the rectangle, but you cannot get the details of the rectangle. Okay, we have built the object. Okay, let me scroll up so that you can see from the beginning what has happened. So we have the init method, we have the class name RectangleTurtle, and we have a couple of small errors that we can correct it, that is thrown by Pylance. We have the data part. Now we have the draw self, where it will draw its own rectangle, and we can actually change the color, size, etc. Also, if you want to get the details, now you can use the give dims and locate home method to get the details of the rectangles that has been created. So what we are going to do now is we are going to go down into the main part of the this script, and we are going to create two rectangle turtles. So how are you going to create it? First of all, we are going to comment them. Okay, it's not correct. I'm going to comment it properly. Just give me a second. Okay, and then I'm going to create a rectangle 1, and I'm going to call the RectangleTurtle object. So when I'm going to call the RectangleTurtle object, it is asking me the various details. So it is asking me the x coordinate, so I'm going to give the same x coordinate of this first rectangle. So I'm going to say 50, and the y coordinate is 150. And you can see as I'm updating the details, this the argument that is getting filled up is highlighted here in blue. The length is going to be 125 and the breadth is going to be 250. So if it is confusing for you, you can actually make it as a key value pair also. Next is I'm going to create one more rectangle object, and this time the coordinate is going to be 200 and the y coordinate is going to be 300 and the length is going to be 100 and the breadth is going to be 75. Apart from this, I'm going to go forward and I'm going to ask the details of the rectangle, and the details of the rectangle is going to be provided by give dims. So if I execute this, it will actually print the dims, and if I say rect2 and if I say locate home, it will locate the home of the rectangle 2. You can go scroll up, and if you want, you can actually add little more information in the methods also. So you can actually give the name for the rectangles. So at the end of the day, how will you know that which particular rectangle is getting called and what to do? So those things you can try to create an additional point here, and you can give a name also for this rectangle. So if I say self dot name, and I can ask for the name from the user itself. So I can say name. So this will it will ask for the name from the user when they are building the method. So I'll say name is a string. So I say it's a string, and then I can use this name here when I am going to locate it. The length of self dot name. So here the name of the rectangle will get printed, and once you are able to build it like this, self dot name rectangle, once you're able to build it like this and play with the way you want it, then there's nothing easier than nothing difficult to visualize. So here we need to give the name now. So if you don't give the name, then it will not be able to create. So you see it is asking for the name. So I say rect1 and I say here rect2. Okay, I've done that, and now I'm going to execute this, and the same way it is going to wait for me to get the input. So I'm going to execute this script. It's going to take a second for it to get through, and I'm going to pull the turtle here, and then I'm going to press enter. And here you see that it is actually not drawing. So it has given all the information. So it has executed it completely, and it has told that the rectangle 1 is 125, rectangle 2 is 200, etc. The reason why it did not draw is we did not ask the objects to draw the rectangle. So that is the problem. We have to ask the rectangle to draw itself, then only it will draw. The reason why I made this mistake is that I want you guys to understand the difference. So here we have actually created the data. We are able to even pull the data, whatever data we gave, 50, 150, 200, everything is coming out. The length, breadth, the location of the home. However, it's not drawing. The reason is because we do not call the method draw self. So once we execute it right now, after we call the draw self, then now it will be able to draw. So you see that it is drawing. So it has gone up, it is drawing there, and after it has drawn, then it has provided the details of the rectangle 125, 25, 200 and 300. And one more point is, you see that this turtle is standing here. That is because we had actually created a single turtle. We had created actually multiple turtles for each of the objects. If you go up, So here we are creating new turtle for every object that we are creating. We don't need to do that. We can create a single turtle like this. We can create one turtle like this, and we can pass the turtle into this object when we create it. That is one way. Or we can inherit the turtle and we can have internally one turtle for this object. There are various ways to do that, and that is called as programming paradigms or object oriented paradigms. Those things are something that if you want me to look into, you can let me know. I will try to provide some update on that, try to make a video on that. And with this particular discussion, now we have come to an end of how to think about object oriented programming, and how to use turtle to understand object oriented programming in a visualization manner. Just a minute. So we have seen a lot in this discussion. So we saw how to create a functional way of creating a rectangle using turtle, and then we moved one step ahead and we created a rectangle turtle class blueprint, and then we created rectangle turtle objects or instances, and then we made those instances to draw the rectangles. We also saw how we can get the data back from those objects, which is not possible when you're going to use functional programming. So with all these things, I suppose that you have got an overview of multiple paradigms, the procedural, the functional, as well as the object oriented paradigm. I believe that you have to practice a lot to get hang of all these paradigms that I have spoken about. So get comfortable with turtle and start working with the various methods that we have introduced in this video and the earlier video. Do leave the comments if you have any questions. I will try to provide my feedback as soon as possible. So with that said, I would like to leave this video with 4 words, that is practice, 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 practice. See you guys. Have a great time.